Thank you, Roma. Welcome, everyone, and thank you for joining today. I just want to start with a simple but exciting question, which is what if you could walk through your factory, test every robot, and feel the environment as if it was real? Sounds cool, right? So I am Hisham Touzani, robotic expert at Dassault System, and today I'm really glad to show you how we can bring factories to life with real-time photorealism and how it can be applied in your industrial needs. So basically, it's not just a demo of the future, it's really happening right now. I'm really excited to walk you through that. Before we dive into the demo and real example, let me give you just a quick overview of what we will cover today. We will start by looking at why photorealism is becoming such a key demand in manufacturing. Then I will walk you through a body-in-white factory use case. We will show how we built an interactive photorealistic virtual twin, and of course, entirely inside the 3D experience platform. And from there, we will explore the rendering engine itself, so which is not everyone know about it, and see DELMIA layout capabilities. We will see also advanced robot simulation, and at the end, we will end up with the VR walkthrough where you will see the factory from an operator point of view. So if you are really interested to see this, just stay till the end. So if it is okay for you, let's move forward. Let's now understand why more and more customers are asking for photorealistic environments. So the first thing that comes to mind is that it becomes a foundation for AI, right? So by generating a high quality synthetic data that can really mimics the complexity and realism of the physical world. So you may have heard that more and more projects and more customers are shifting from rule-based robotics to AI training, and especially in dynamic environments, which drive demand for large-scale synthetic data. And basically, I'm referring to vision systems and robots involving in dynamic environments like mobile robots, for example. The second point is that we have the collaboration aspect because teams need to collaborate in the same virtual twin, and this add more context to their work. And of course, the third point is that it can also build trust with stakeholders because if they can see, understand, then they can validate the concept visually. Okay, so if we can design, plan, and simulate, what's really stopping us from delivering a photorealistic environment, and of course, an interactive virtual twin in real time entirely in the 3D experience platform. So basically, no plugins, no external render engines, just real-time rendering and simulation using the native 3D experience tools. So on your left side, you can see here the before and after, where we really went from basic geometry and lightings to a fully immersive environment with realistic materials, with realistic reflections and behaviors. So I will show you in a second how we did that, and I will show you all our capabilities. So today, this project is a direct expression of Dassault System vision, where we bring together design, simulation, manufacturing, and collaboration inside one unified platform, grouping all together the 7 pillars from the virtual twin to generative experience to virtual companion and to sense computing. So in my opinion, this will have a huge impact satisfying the needs of our customers today. And talking about the needs, we have identified or we are seeing three major pain points across manufacturing. So the first one is the need for scalable AI training, and that start with synthetic data generation. And basically, what is used to require massive manual labeling and real world capture can now basically generated inside the virtual twin with varying many parameters like lightings, angle, object variation, and environment, which help train the AI model and make them more generalized. The second point that you can see in the middle is the need to train an onboard operator, especially in complex environments where security matters. And basically, immersive collaboration let also teams practice, validate their ergonomics, and even refine tasks in order to anticipate for errors. And the third point, as discussed earlier, is the need to convince stakeholders, for example, for internal sign-off or customer validation. Photorealistic environments make the concept more clear. So just keep in mind that this is where the industry is headed today, and we are already building the tools to meet those needs today. Now, let's be honest. Visual quality is something people notice immediately. And today we are working with the 3D, so it's the first thing we notice. And as you can see, just by varying the ambience, we can see a huge difference. And I don't know if you are aware, we have out-of-the-box functions where we have a good rendering, introducing the lighting, the reflection, and so on. As you can see here, we see the reflection just by changing the visual quality, and where we introduce real shadows, reflections, and so on. So the other parameter is the ambience and the materials. So as you can see, we have a wide library of materials, and basically it's one thing to have the right geometrical layout, but when you start applying realistic material like, I don't know, steel, rubber, glass, or paint, and if you choose the correct texture, everything just clicks visually. So basically, you get really this sense of realism, and this is where, like, I don't know, you refer to something you have seen in the real world because you have the right materials, the right reflections. And as you can see in this example, we have also wide library of ambiances that you can really use out of the box, but you can also import your ambience from an external source. So we are compatible with that. So here you can see that just by varying the ambience, the lighting changes. So it adds also more realism if you play with the parameters and so on. So moving to the design and styling, this example focuses on how to import existing materials. So basically, in this example, we play with the texture. So I have imported like the material that I have created inside the 3D Experience platform. And in this example, you see how we applied this to the equipment, such as the robot in this case. I can vary the metallic side of the robot. I can even vary the texture of the robot and so on. So I have created many parameters to make the robot more shiny, more real. So this also helped to add realism into your factory. And then moving to the weld gun, we have done similar things. So we have adjusted also the materials of the gun and so on. And we did that on the factory itself. So in the second part, we can see how we brought AI into the creative and styling phase of the product design. So we have basically the noising capabilities because basically a high quality rendering usually comes with high computational costs, especially when simulating lighting and reflections. And our AI-based denoising model predicts the final results quality in real time. So you can see on your left, this is without denoiser. On your right with the denoiser. You can see that with the denoiser, we are conversion really quickly to a final image with a good quality. So it's like a matter of 1 second or less. We are conversion really quickly to this. So all of this to deliver photorealistic visuals. So this slide shows how we bring the physical world into the virtual one and vice versa. So I'm talking about the green field. So starting for the regarding the layout creation, we can see on the left, we start with the point cloud object retrieval. So we import our point cloud, and we can also use our AI capabilities to detect objects in the scene like robots and so on. And even we go further by even identifying the object that you have in your database and replacing them all together. So if you have many equipments inside your scene, so we are capable of first identifying them from your database and then replacing them directly on your tool cloud. But of course, you can still use also the tool cloud for collision detection and so on. So the third part is, I would say, the scope of this project, because we started from a greenfield where we have used DELMIA plant layout solution in order to build such a factory. So we have used all the capabilities that we have inside DELMIA layout, the snapping capabilities, the measurement, 2D sections, and so on. So this was really helpful in order to create such a virtual twin. Okay, now moving to the robot simulation part when we need to simulate. So basically, we have used also best-in-class algorithm proposed by DELMIA in order to simulate, but also to generate the path automatically. So basically, I'm picking this example because it's really interesting. So starting from a task where we had many collisions, as you may see here in the screen. And basically, we start from this task when you have only spot operations in your task. You may have also some home position from the top to the end. And here you can see that it's not really an obvious movement to solve. Here we are just having spot operation in our task. So we are giving it as input. And we are using our robot optimization app in order to solve that. So basically, instead of doing the via points manually, our algorithm is able to do this for you. So it's automatically generating via points between the spot operation where you have the collision. So first, in order to solve the collision, but also in order to minimize the cycle time. So, and as you may see, so we can start first by validating the internal task or validating the input task. So basically, it will check if everything is okay or if you have any collisions while moving from a segment target. And basically, we can even go further by optimizing the degrees of freedom. So basically, to reach a point in space, you may have more than one configuration. And optimizing the degrees of freedom means that we will reduce the configuration changes, which can be necessary in some cases and can also drastically reduce the cycle time. But we can also go even further because we can include gradually or even at once a lot of constraints such as the gun values, so the opening and closing of the gun. We can introduce the config and turns and even add some flyby motions. So as you can see here, so we just compute our task to get a task free of collision, but also the algorithm is picking for you the best trajectory, which minimize the cycle time. So after some calculation, we will see how the algorithm will introduce the via point. So here's the algorithm is checking for the best possible option. And at the end, we have one task without any collision while minimizing the cycle time. So as you may see, the algorithm introduced automatically the via points. It introduced also the opening and closing for the gun, so the 7th axis of the robot, and everything automatically. So this saved us a lot of time in order to simulate our robot inside this virtual twin. The other part is connecting to a real VRC. So you can see with such photorealistic visuals, we can even work in it real time. We can connect to the VRC, virtual robot controller. And in this case, we picked the FANUC robot. And you can see that we can even start the teach pendant from the 3D experience platform. Basically, so we can transfer the robot program like from a backup or something, or even teach the robot. So you may have operators that are really familiar with FANUC teach pendant. So it can be used also for training in the virtual twin by using real teach pendant. So as you can see here, we can teach the robot as the following. And basically, we can also do more than this because starting from DELMIA, you can do your program in DELMIA, you can create your task, and we will translate everything in the background and send it directly to the VRC. So basically what you have to do just to click to pick your task, connect your VRC, and then click on play, and we do everything for you. So basically it's transparent for the user so because the translation and the and sending this to the VRC is done in the background. And coming to the real-time photorealistic rendering, so you can see that one of our differentiators is that we are real-time. We do everything all in one platform, and we are working directly on the authoring data, so which means no data conversion. So we can design in CATIA and then move to DELMIA for simulation or planning, then go to the virtual commissioning when you connect to VRCs, when you have your virtual twin and your PLCs all interfaced in one platform. So this is a huge differentiator that we are proposing today. So what I propose now is to let you watch a video explaining more the journey from the design to photorealistic simulation, where you will learn more about how we started and how we get to this photorealistic simulation. So just enjoy.
3D Experience is redefining industrial digital twins by bringing design, simulation, and real-time collaboration together in a photorealistic 3D universe, opening a new era of immersive manufacturing. From the structure to the last robot weld, every detail is accounted for, visualized, tested, and validated before a single machine is powered on. This is not a render. This is the future of manufacturing, authoring in real time with full fidelity. Welcome to the 3D universe powered by the 3D Experience platform. In today's fast-paced industrial world, success depends on your ability to move from concept to execution without friction. That's why we've unified best-in-class technologies. CATIA for design and DELMIA for robotic simulation, all in one platform, in one data model. No imports, no conversions, no compromises. The 3D universe is not a visualization tool. It's a live, interactive virtual twin where engineers design, simulate, and optimize manufacturing logic directly inside the operational environment. Whether you're planning the factory layout or refining multi-robot interlocks, every move happens in context, accurate, reactive, and ready for production. But the value goes far beyond simulation. This immersive twin becomes the foundation for AI with synthetic data generation, feeding smarter logic into robotics, vision systems, and production analytics. You don't just simulate reality, you use it to train and improve. Operators step into the process early, practicing tasks, validating ergonomics, and identifying risks, all within a high-fidelity, immersive environment. When teams work inside the same twin, whether in design, manufacturing, or logistics, collaboration becomes immediate and grounded in real processes. This is manufacturing without guesswork. A virtual twin built not just to impress, but to produce, improve, and evolve. It's a new foundation for manufacturing agility, powered by unified authoring, real-time simulation, and immersive training only possible inside the 3D Experience platform. You've seen what's possible. Now build what's next with DELMIA Robotics.
I hope you enjoyed the video. and let's move forward. So now coming to the virtual reality and photorealistic environment. So basically, if we can build this realistic virtual twin, like what's stopping us from stepping inside? Basically, this is what we will be showing. But before, I will be showing you all our capabilities in VR today, or at least the best functions that we have today, starting from simulating and animating your task. So basically, you can reuse your task or simulation in DELMIA inside the VR. So you can simulate using our VR for manufacturing function, which enables you to simulate and animate all the tasks that have been performed in order to discuss with the colleagues and to have to anticipate even for errors. So basically on the right side, you can see that we can also propose collaboration inside VR, where your teammate or your colleague, you can be, I don't know, in one site here and one site in another country, but you meet inside this virtual twin to have more conceptual vision. You can start challenging the layout even before it will be built physically. So, and of course, this concept is really useful, especially when you collaborate with teammates. This adds more value when you work inside the virtual twin. And also you can even go further by interacting with the object in VR. So think about, I don't know, a meeting inside the VR, and you may want to challenge a layout. So you need to, I don't know, propose or snap some equipments inside the virtual twin to see if you have some blocking issues or if you need more space for your process and you want to do this directly into the VR. This is also possible. You can also use this for ergonomics issues to have exactly to know exactly how it will look like in the real world. And on the second right side, you see that we have also like the human design where AI enhances gesture and motion capture for virtual humans. So this allows us to simulate realistic human interaction in immersive environments. For example, to validate user ergonomics, to also improve the posture or other interactions with the product. So our AI model increases the realism and fluidity of human avatars, which is also really interesting. So to summarize, VR with high realistic rendering helps with ergonomics, helps train and team or train your operator and improve the team collaboration. And now, as promised at the beginning, I will give you the opportunity to put your virtual headset and step with me inside the factory from an operator point of view. So let's do it.
Manufacturing is evolving, with immersive reality driving greater efficiency. Today, join Hee Cham, a robotics expert at Dassault Systems, as we step inside an automotive BIW factory, where every stage, from design to validation, was developed within the 3D experience platform. Let's see how VR transforms how teams collaborate, validate, and optimize production. In this first scenario, we enter a fully simulated BIW assembly line. Designed in CATIA and programmed, simulated, and validated in DELMIA, this virtual factory allows teams to assess every process before physical implementation. Using VR controllers, engineers can navigate the shop floor, take precise measurements, and interact with the environment in real time. By animating the robot's movements using DELMIA's programming, engineers can identify layout issues and immediately discuss potential solutions. With VR, factory layouts become dynamic, enabling engineers to reposition workstations and adjust structural elements. Operators can experience human pitch in virtual reality, practicing their movements and actions before entering the physical factory. By simulating realistic environments and tasks, they gain hands-on experience and familiarize themselves with the industrial processes, all within a safe, immersive training space. VR excels in testing emergency scenarios. Here, we stop the production line to simulate an urgent situation. Engineers and operators can practice interventions in real time, ensuring they're prepared for unforeseen challenges. Operator safety is a priority. VR lets engineers simulate human movements in real-world tasks, such as overhead welding or heavy part lifting. By replicating reachability and strain, potential ergonomic risks are identified early, helping to reduce workplace injuries. Teams gain spatial awareness and collaborative agility that flat screens simply cannot replicate. From faster validation to fewer physical trials, immersive technology is transforming factory operations. Want to accelerate your industrialization process? Explore the power of VR with 3D experience.